Hi everybody. The next we are going to discuss about the ARM pipelining and registers. So we already discussed about the ARM architecture and how it will be useful in the real-time applications and what's the main advantages where we used that and all we discuss. And next we are discuss about the ARM architecture pipelining and registers. The very important one. So where we use the ARM architecture is a process we are using the modern mobile communications. We are using that mainly used in the embedded systems. So we fix it in a single devices or single chip, that is SoC. It's called as a ARM processor. Mainly we can able to perform and increase the power efficiency and compact of instruction set, as well as everything will be in a single pipeline with the robust of registers in the data management, that is called as a ARM architecture and the pipeline. We can register everything, we can store, and we can get the information through the pipeline. That is called as a main functions of pipelining of ARM architecture. The main concepts of the pipeline is breaking the instruction execution of the systems, where we stored and we can assemble the instruction set, where we can execute it with the sequence manner. That is called as a main concept of the assembling and the line. And the main goal is to increase the instruction set and we increase the throughput. That is called as a main goal, and it's not a necessary to single instruction or a speed. That is the main important goal. And what's the benefit in addition to achieve the higher clock frequencies and better resources utilization? That is a main important thing of assembly line, and it mainly used for the CPU pipeline. What's the main challenges what we focused in the sense? The hazards, the pipelining of the hazards handling is very difficult. That's the main challenges of the pipelining. This like is information we can assembling the information through the pipeline manner. That is called as assembly line. And mainly we have the 3 stages and the 5 stages of pipelining organization is available. First we focus the 3 stages, where we in the sense is solve, decode and execute. That's the main thing, where we in the sense fetch, decode and execute. That is FDE. That is fetch in the sense that's read the instruction from the memory. That is called as a fetching. We get the information, we are collecting the information, we are fetching the information from the memory. That is called as a fetch. Decode in the sense we decode the instructions. That is encoding and decoding. We decode the instructions, that is demodify the instructions and identifying the operation, what we are going to do, whether it may be addition or subtraction, multiplication, division, whatever it may be. What's our operations? That is identifying. That is called as a decode. The execution to perform the operation, what they are giving the instructions, for that instruction will react or it will perform. That is called as a execute. FDE. That is fetch, decode and execute. These are very important things of 3 stages of pipeline. And mainly the 5 stages, what's in the sense fetch, decode, execute. Additionally we can add these 2, that is called as a memory, and other one is a write back, that is called as a W, that is a write back. So in addition to that, access of data from the load or stored information, what we see in the previous topic, that is usual unusual memory storage we can use. We can load or sharing the information or store the information by using this memory. That is called as a ARM file. And another final 5th stage is something about a write back. That is called as a write the result or destination to the register, where we stored and what's the performance we executed. Everything will be stored. Fetching, decoding, executing, memory unit and other the write. That is FDEMW. That is called as a main functions of this program. That is Cortex-A series, and we are using the BlackBerry phones and everything. That's ARM11, ARM9. We can use the multiples of operation it will be support. That is called as a ARM 5 stages of the pipeline organization. This ARM register set mainly where we use the core management in the sense it's a general purpose. There's a general purpose register and a special function. There's a special purpose of register and a program status register. That is a status register. That is a PSRs. That's we have RO R12. That is called as 13 bits of register. It will be wide of 32 bits and use it for the general purpose data storage and manipulation. We can use for the general purpose register, mainly R0 to R12. Okay, and then the other thing is a special purpose register, that is R13. That is SP, the special function, that is stack pointer, and R14 is nothing but LR, that is a link registers, and mainly we are using the return of the address and or calls, and that is R15 mainly counter used for the next instruction set. And other thing is nothing but a special, that is a special function of program status, mainly that is CPSR and SPSR, that is a current file SPR and the flag and interrupts, and other thing is to save the CPR during the execution. That's the exception of the function. That's the main thing. That's R02, R12, and R13, R14, R15 are comes under the special purpose, and the remaining things are comes under the special programming status of the registers. Next one is assessment queries. So we can assess here. So this is the answer for the assessment questions. Mainly the conclusion of this pipelining, where pipelining is mainly the fundamental CPU of optimization for the parallel instruction set of execution. That's the main important thing. And ARM evolution, mainly the transition from the stage 3 to stage 5 for the performance. So stage 3 to stage 5. We already discussed ARM 11, ARM 9, and ARM smartphones. We are using this ARM 5 processor. And a register set that mainly using the critical and efficient data handling purpose. We are using this register set we are using. So these are the main architecture and the fundamentals of the ARM processor thing. Thank you.